archives is a collection of documents of an immense importance to mankind, of universal importance to mankind. It is also of national importance to Israel and to the Jewish people. It holds about 80,000 documents, archival material, that shed light on everything that Einstein represented. Now, we shall talk today mainly about his science. But having said that, he was one of the greatest scientists of all times, the greatest scientist of the 20th century. But as I said, having said that, he was the individual who expressed his views on every issue that was on the agenda of mankind. His fame comes from his science, but attention was given to his personality and his views also outside the world of physics. And in numerous articles, in correspondence, in letters, in public addresses, he expressed his views on everything. And what is everything? The first half of the 20th century is a very dramatic era in the history of mankind, and Einstein talked and wrote and corresponded on such issues as nationality and nationalism, as war and peace, human liberty and dignity, God, religion, Zionism and anti-Semitism, the Hebrew University, etc. And he was controversial. He expressed his views bluntly, often considered simple-minded, but still his position had an impact. But today we are going to talk about his science. Now, Einstein in his life had two very creative years, like a volcanic eruption of creativity. One was in the year 1905, to which we refer as the Annus Mirabilis, the miraculous year, and the other one was in November 1915. Now, what is interesting to point out, that these 2 years, these two eruptions of creativity were preceded by passionate love affairs. The first with Mileva, who then became his first wife, and then with Elsa, who then became the second wife. So think about it. Maybe we have here a prescription for creativity. So what happened in those years? In the miraculous years, with a number of papers, he really established modern physics. He proved for the first time the real existence of atoms and molecules. Now, for us, it is very clear. Even people who did not study physics know that matter is composed of atoms and molecules. They are real, they have weight, they can be counted. In 1905, most physicists still did not believe that atoms and molecules are real. There were anti-atomists, there were other explanations. They knew that it was maybe this kind of a model, but the reality was first provided for proof by Einstein. Then he contributed and established our modern understanding of the nature of life, and then came the special theory of relativity, and this most famous combination of 5 symbols, E equals mc squared, and I shall say a few words about the latter mass. And then in 1915, the general theory of relativity, which is a new concept, a revolutionized understanding of our universe, of space, time, gravitation. Now, not only did he in these 2 years produce such outstanding achievements, and not only were they maybe preceded, maybe motivated, maybe energized by passionate love affairs, it is also interesting to point out under what conditions this was achieved. So in Annus Mirabilis, the first year, Einstein was 26 years old. He was not working at the university. He was fully employed in the patent office in Bern. So everything he did in his free time. And on top of that, he had a little boy, 1 year old, sitting in his lap when he came home from work. And in November 1915, it was still the Great War, World War I. Europe was devastated. Einstein was under criticism as a political opponent of German militarism. His family broke up. That passionate love affair with Mileva faded away. Mileva returned with children to Zurich, but still Berlin maintained this inspiring atmosphere, and people did science. And the scholar, the historian of science, said that in spite of everything, this general theory of relativity could not have been done anywhere else but in Berlin, and by no one else but Einstein. We can discuss that later, why. And then now begins your 10 minutes lesson in physics, and to be continued by my friend, colleague Miguel later. So that will be the second part of the course. And you see, this gentleman sits in a train, and the train is moving with constant velocity, and he does not miss the cut. And there is nothing that this man on the train can do to tell him if the train is moving or is not moving with reference to the platform, as long as it is constant velocity. This is called the principle of relativity. Einstein argued, assumed, that there is nothing that he can do, not only this Coffee-Gedanken experiment, as our moderator mentioned, nothing he can do to tell him if the train is moving or not. And if you add to that also another assumption that the velocity of light is independent of the source, of the observer, of anything, then these are the two principles. This is the special theory of relativity. From this, everything follows, and if two observers measure the length of a rod, one observer is on a train, one observer is outside of the train, they will not agree on the result. If they measure the time between two events using same clocks, but at different places, they will also not agree. Moreover, if they look at two events, they will not even agree which happened earlier and which happened later. This is counterintuitive, but this is physics. This is how our world behaves. And from that follows this most important equation. E is energy, m is mass, c is the velocity of light. C is a huge number. A huge number squared is an even greater number. So this tells you that under certain conditions, a small amount of mass can be converted into a huge amount of energy, and this is the basis of such phenomena as the atom bomb, in which a certain element, uranium, is split into two other elements. The mass of the two other elements is smaller than that of uranium. The difference is that energy, E equals mc squared. And if you can do it under controlled conditions, you have a nuclear reactor, and it happens all the time in the core of our sun, and of all the stars. There are certain particles which merge, form another particle, certain mass is lost, and this is the source of all our solar energy and therefore directly and indirectly the source of energy on our planet and of life. And you see, this is such an important equation that it appears on numerous commercial products. And anybody who wants to produce such a product and use this equation has to pay royalties to the Hebrew University. Why? Because that was his wish. And I don't think that there is a single country which did not produce a stamp with E equals mc squared. And caricaturists consider this as a summit of human evolution, and maybe here is another one that he tried other things before he got his E equals mc squared. And now we go to the next stage. Now I'm going to teach you what is the general theory of relativity. Now you see there is this myth that there is this tower in Pisa and Galileo used to drop objects, and no matter their composition, of their size, of their weight, they fell on the ground at the same time. Why do I say it's a myth? He didn't go up there, he didn't have to throw these things, he knew that they will fall at the same time. Everybody knew that. All physicists knew that. Einstein made this the cornerstone of his greatest discovery, the general theory of relativity. And what can you say? For example, look at this rocket. There is this lady, and this rocket is accelerated upwards, and she is dropping two objects, and they, of course, reach the floor at the same time, because the floor reaches them at the same time. But now suppose that this rocket is on Earth, is not accelerated, and she drops them. They will also reach the floor at the same time, because there is gravitation. And Einstein had this insight. The gravitation and acceleration are one and the same thing, and this is the equivalence principle, and he said that that was the happiest thought of his life, but still it took him 8 more years. And after these 8 years, he produced the general theory of relativity. And the general theory of relativity is a conceptual revolution in our understanding of gravity. In Newton's physics, gravity is a force that attracts two bodies. In Einstein physics, it's not a force. It is a property of space and time. And such concepts as curved space appear, and matter curved space, massive bodies and light move in curved space. Now, this general theory of relativity is the source, the origin of everything that Einstein's physics represents now. That is what Miguel will talk about. This is the basis of modern cosmology and of such concepts as the Big Bang theory, how the universe started, how it evolved, what is its structure. It is all in those equations produced by Einstein. The concept of black holes. Nobody doubts that they exist. They are these esoteric celestial bodies that are not exceptions. They are the nature of the universe. And finally, the gravitational waves, which were accepted. And I am going to conclude. My last slide is one of the predictions of the general theory of gravity is that clocks on the planet Earth will be delayed with respect to clocks up there in space in the satellite. Time, the rate of time, depends on the strength of the gravitational field. This is a deep, very important consequence. Now, we know that. And if we did not know that, we would not have GPS technology. What is GPS technology? All the time we have 24 satellites orbiting around the Earth. From every point of the Earth, you always have line connected to 4 of them. Every GPS device that you have, your clock, your car, sends signals to those satellites. The signals are returned. You somehow measure the time. But of course, the time for the signal to go there and back depends on the rate of time there compared to here. Had we not known that, our GPS technology would introduce errors of the order of 10 kilometers a day. So this is Einstein of yesterday, mainly Einstein, the introduction to science of today. And now I turn it over to Miguel, and just to conclude with